Hello, welcome again. We are solving Indian Forest Services Mechanical Engineering paper 2 of year 2022. Question number 2A is tank A of volume 500 liter contains air at room temperature and 700 kPa pressure. Cylinder B is initially empty and has a piston of mass 100 kg and cross section area 0.5 meter square and linear spring with spring constant 150 kN per meter as shown in the figure. Now the valve is opened and air flows slowly and steadily into cylinder B. The entire system eventually reaches room temperature. Assume air as an ideal gas and atmospheric pressure as 101 kPa. Draw entire process PV diagram for air in cylinder B. Determine 1. Pressure when piston just reaches the spring. 2. Whether the piston will be at the stop in the final state. 3. Final pressure of air. 4. Work done during each process. So here this is the tank A, this is cylinder B, this is piston, this is spring, and spring is 0.3 meter above this cylinder B, this piston, and stop at 0.5 meter above this piston. So now first when the air will come to this through this valve, first the piston will be displaced up to this point at constant pressure, and this constant pressure is pressure of atmosphere plus piston wind. Okay. So the initial volume for cylinder B when the piston hasn't displaced is 0, and when the piston reaches the spring, the volume becomes because spring is 0.3 meter above this spring and area of piston is 0.5 meter square. So volume is volume V2 becomes 0.5 into 0.3 is 0.15 meter cube. Okay. So 1 2 is the process. This is a constant pressure process. 1 2 is the process from the start to up to the spring, which is constant pressure process. And this constant pressure is atmospheric pressure plus weight the pressure due to weight of piston, and weight of piston is mass of piston is given as 100 kg, and so weight is 100 into 9.81 100 into 9.81 and dividing by area is 0.5. So this will be in pressure in Pascal, so converting this in kilopascal by dividing 1000, so it will be 102.962 kPa. Okay. So pressure, this constant pressure will be your 102.962 kPa. So up to spring the pressure will remain same, that is 102.962 kPa, and work done will be in constant pressure process is your pressure into change in volume, and initial volume is if we consider only cylinder B, the initial volume is 0 and final volume is 0.15. So change in volume is 0.15. So work done comes out as 15.4443 kilojoule for this process in kilojoule because it is in kPa. Okay. So now once the piston has reached this spring, then the constant pressure process will not take place, because some work has to be done for compressing the spring, and some work has to be done for displacement of spring up to stop. So that combined work make the process full total. But the work done can be calculated by work required for compressing the spring plus constant pressure work from 0.3 to 0.5. So that is the total work. But it will be actually a polytropic process because compression of spring has to be taken into account. But if we take compression of spring plus constant pressure process, then we can also calculate work. So work done in compressing spring is potential energy increased, so that is half kx square. K is your spring stiffness, that is 150 kilonewton per meter, and x is displacement, because displacement is from point 3 to point 5. Okay, so that is the energy required for compressing a spring. And if we consider the process without spring, then it will be a constant pressure process. So without spring, the work done will be your P into change in volume, and change in volume is uh, final volume is according to final volume is according to this length, point 0.5 into point 0.5 into this area of 0.25, and initial volume is point 0.3 into point 0.5. This volume, final volume is this volume, and initial volume is this volume for process 2 3. Okay, so that work can be calculated if we consider a constant pressure process plus this compression of spring, and compression work required for compression of spring. So work required for compression of spring is this, and if the compression would not be there, then the work done would be this. Okay, so but now extra thing is your spring, so we have to take into account the compression of spring also. So that is the work done during process totally. And in a PV diagram it will be written like this: PV dash for n is polytropic index. Okay, so work done comes as 13.2962. Now the piston has reached the stop, and it will not move above further, so volume will remain constant. So 3 to 4 is a constant volume process. No work will be done in this process. So total work is your work of 1 2 and work of 2 3. Okay, and now the final volume of cylinder B is V4. V4 or V3, that is same, that is 0.5, 0.25, that we have calculated, we have used here also. Okay, and final temperature is room temperature, because the gas in the tank is at room temperature, and final temperature is also room temperature. So means final temperature is your initial temperature. Now if we consider this as a total system, tank A plus tank B or cylinder B, then the initial volume is this cylinder volume of this tank A, and final volume is volume of tank A plus volume of cylinder B. Okay, so and initial pressure is 700 kPa. So initial pressure is 700 kPa, and for final pressure is P4, and final volume is a summation of these two. Volume of cylinder A, volume of tank A is just 500 liter of 0.5 meter cube. Okay, and V4 is 0.25. So that final volume comes as 0.75, and initial volume is only the tank A. So for constant temperature process, P1 V1 should be equal to P4 summation of this final volume. Final volume is V4 plus V1, volume of A plus volume of B. Okay, so from this we can find out final pressure. Final pressure comes as 4466.66 kPa. Okay, so now final pressure is this, but the pressure exerted by atmosphere, piston weight, and spring is this. This is the spring stiffness, this is area of piston, and this is your displacement of spring. So that will make spring pressure, and this we have already calculated, atmospheric pressure plus weight of the piston, pressure calculated by this. So this comes as 162.962 kPa. As the piston, atmosphere, and spring are exerting less pressure, so the piston uh, will will be on the top of, will be near the stop. So as final pressure is